Hello everybody, this is the notes for Calculus section 1.1. Alright, so some of you have had notes online before like this, others of you haven't, and it's no big deal. So some things to keep in mind. One is use the pause button. Hit pause so you can copy some things down, and then once you got it copied down, hit play, then you can hear the explanation of what these things are or why it is this way, and hear me talk. The other thing is when you come up to examples or when we start doing examples, do the same thing. Hit pause, take your time, work your way through the problem, and then hit play again, and then you can make sure that you did things right and hear some explanations of why this is. Or if you get stuck with the example, then you can listen to me go through and work through the problem. All right, I hope this works out for everybody. So, in this first section, like I had mentioned in class, the big idea, one of the big ideas of calculus is the idea of a derivative. A derivative is really just a slope of a line. And so, yes, this is Algebra 1 material, but it's really important for calculus. So, we're talking about it again. So, the slope, always use that lowercase m. We know it's rise over run. Another way to word this is change in y over change in x. This notation might be new for some of you. That little triangle is called a delta. So we can say delta y over delta x. All that really means is change in. Okay, that's what that symbol is. It's just the change in the y values divided by the change in the x values. So delta y over delta x. And then this fraction here, that is, everybody should know that one. Difference in the y's divided by difference in the x's. All right, so some other things. Slope of a horizontal line, that is 0. The slope for a vertical line is undefined. Undefined means there is no value for it, and we just say it's an undefined slope. Other common things with slope, parallel lines, they got the same slope, and perpendicular lines. There's a couple ways you can define perpendicular lines. Most textbooks like to say the product, if two lines are perpendicular, the product of their slopes is going to be -1. I never really liked that definition. Never really helped me get, if I had this slope, it never helped me get the other slope. So I like this definition better. Perpendicular lines have slopes that are opposite reciprocals of each other. Okay, so some different equations for finding the equation for a line. This one, y equals mxb, most common, everybody knows that one. It's called the slope-intercept form. The value of m is the slope. The value of b is the y-intercept, where that line crosses the y-axis. That's the one we use almost all the time. That's just how it's just natural. It just fits with lines. So, the other equation, this next one, I always understood it, but I never really liked using it until I started teaching this class a couple years ago. And the more I used it, the more I liked it. It's called point-slope form. So you use it when you know the slope of a line and you know a point that the line is going through. Okay, so that point that you know is this x1, y1. And so you'd plug them in here and here. The other y and x are just the equations that you see in this y and that x right there. They just stay in the equation. So you're plugging in a slope and you're plugging in the x and y coordinates of the one point that you know the line goes through. And we'll do some examples with this, but like I said, I'm starting to like this point slope form more and more. Vertical lines. The equation is x equals a number. Okay, whatever point that vertical line goes through or wherever it crosses the x-axis, that's the equation. It's x equals that value. Horizontal lines, y equals a number. So that number is the y-intercept, or it's the y coordinate of the point that this horizontal line goes through. Okay, that's all basic stuff. This is all things that should be reviewed. So the first example, find an equation of a line that passes through those 2 points. First thing you need to have is the slope. So change in the y values. From 4 to -2, we are decreasing by 6 over the change in the x values. We are going from an x value of 5 to -10, so we are decreasing by 15. So if we clean this up a little bit, the negatives cancel out, common factor of 3, We got 2/5. There's the slope of our line. Okay, what I'm going to do is pick one point, and I'm going to go with the ones that are positive. Okay, so that 0.54, that point slope form. You go y minus the y coordinate of the point that the line's going through, equal to the slope, multiplied by x minus the x coordinate of the point that the line goes through. And so now we just clean it up and put it into the slope-intercept form. So we're going to solve for y. But we got some distributive property to work through. We get this. Then we're going to add 4 to both sides to get y by itself. So 2/5 is the slope times x. When we add 4, we get a plus 2. There's the equation of the line that goes through those 2 points. Okay, simple enough. Next example, a little bit more work, but same thought process. You need to have, if you're going to write an equation, the question says, find the equation of the line. You need to know the slope, and you need to know a point that it goes through. Now, we have a point that the line is going through. That's that 0.35. So what we need is the slope of the line. The line that we're trying to write the equation for, it's going to be perpendicular to this equation. So what we need to know is, what is the slope of this line? 2x plus 5y equals 4. To know the slope of a line, put it into the slope-intercept form, which means solve for y. So I'm going to subtract 2x from both sides. Going to divide everything by 5. Y equals a negative 2/5 x. So each term in that numerator gets divided by 5 plus 4/5. What we're really concerned with, though, is just the slope of this line, which is the negative 2/5. Now, we don't want that number. Our line that we're trying to write the equation for is perpendicular to that. So the slope, and hopefully you remember from geometry, this little notation, it's like an upside down capital T. It means perpendicular. The slope of the line perpendicular to this one is going to be the opposite reciprocal. So opposite, we're just changing the sign. It was negative, now it's positive. The reciprocal, flip that fraction over. There's the slope of our line. So point slope form again. We have y minus the y coordinate of the point the line goes through, equal to the slope, 5/2, times x minus the x coordinate of the point the line goes through. And now just solve for y. So y minus 5 equals a 5/2 x minus 15/2. So 5/2 x, I'm going to add 5 to both sides, but adding fractions. So I got to get common denominators. So if I add 5 to have a denominator 2, that's got to be a plus 10/2. And so what we're looking at is y equals 5/2 x minus 5/2. There's the equation of our line that is perpendicular to the given line and goes through the point 3,5. All right, that is it. I will see you in class. We'll talk about just another example, see if you had any questions or concerns with watching the notes on here, and we'll go from there. Have a good night.